Hi, these images show an example of what we mean by image segmentation. The images here are typical photos with complex objects and backgrounds. These ones contain elephants and people, and we've segmented these images. We've used a software algorithm to detect objects in the scene, such as elephants, people, and so on, and we've categorized each of these segments with a unique color. Okay, so what about some real-world examples? As we'll see, image segmentation is used today in an extraordinary variety of problems and domains such as automotive, drone, industrial inspection, as well as in medical imaging, image retrieval, and so on and so on. Microsoft's Inner Eye, shown here, uses machine learning for automatic analysis of 3D radiological images. It uses deep decision forests and cognitive toolkit CNNs to assist medical practitioners. Go have a look at this project, it looks really exciting. In the image, we're detecting that there is a human face in the image, but we're not detecting whose face or anything else about the face, like an emotion, for instance. We can build applications around this knowledge. So, for example, we can have an application that counts faces in an airport to estimate how many people are entering the airport per hour and help the airport manage its operations. If we can detect a face, can we do a little more? Sure, we can recognize a particular face. So, for example, if we have an elderly relative, their smart doorbell can photograph unknown faces and send us a push notification if a stranger turns up at their door. Emotion recognition is another area of interest. Toy makers are experimenting with toys that interact with children based on the child's emotions. Automakers are interested in detecting driver fatigue. The eyes offer a lot of information regarding a driver's mental alertness. Gesture recognition, for example, for remote controlling TV equipment, in the gaming industry, or in the area of hand wash and hygiene, which is a surprisingly large domain of interest at the moment, often depends on being able to separate the hand from the background. In the industrial area, there is a large body of computer vision applications used to manage product quality. These algorithms are used, for example, to automatically sort tomatoes and other produce by ripeness and color, and other factors such as conformity to a norm that appeals to consumers. Free-flow tolling depends on being able to segment the video sufficiently well to identify the vast majority of license plates automatically. And smart cities need to count cars to manage traffic more effectively. To count a car, you need to detect a car. And one way of doing this is by using image segmentation. The oil and gas industry spends a lot of money each year checking their subsea structures, things like pipes and chains. They need to differentiate between these structures and the background. The entertainment industry is an incredibly sophisticated area within the world of image segmentation. There's enormous interest in more sophisticated image segmentation techniques than the traditional green room. There's significant work happening around satellite imagery. For example, the stock markets want to know if, for instance, Walmart car parks are fuller this month than last month, and they can buy that as a service. That service depends on image analysis of car parks and cars. The security industry is very interested in image analysis right now. Instead of constantly monitoring cameras at night, just record the segments of video that include a human being and only store these for further analysis. Much more efficient. In the automotive industry, brake light detection, pedestrian detection, obstacle detection, road detection, lane detection, speed limit sign detection, all active areas of development at the moment. Now, let's look at some of the types of images we'll end up segmenting in this course. Complex images with complex objects and complex backgrounds. No custom pre-processing. Here's a person in the scene. Notice, unlike algorithms such as HOG, the semantic segmentation is neither fooled by his hat, nor by his stance, nor by the fact that we're viewing him from a slightly unusual angle. The segmentation algorithm here is finding someone on a horse, off the ground, in a very different pose to the person in the previous picture. Look at the people further back in the scene. They are standing behind each other. We refer to this as occlusion, and classically this is quite difficult to segment, but no problem to this semantic segmentation-based approach. Look at the posture of the girl in yellow. Typically this sort of posture has also been very difficult to detect using non-neural network-based approaches, but causes no problems here. If you look at her like a computer normally would, she's not in a common human posture. She's not facing the camera, You can't really see her head at all, and it looks like she only has one leg. You also see a limitation of the algorithm. It has detected the statue as a person. Let's go back to segmenting animals. Notice that horses identified very effectively. The algorithm is able to quite clearly distinguish between the horse and the rider. Notice that the neural network has found the dog in this scene, despite the fact that the dog is in quite an unusual posture for a dog. Normally they are on all four legs. Despite this, the neural network is sufficiently confident to mark that object as a dog. The traffic in this scene is effectively segmented. You'll see some flicker. This is because as each frame is processed, the objects are colored in the order that the algorithm finds them in each frame, independently from all the other frames. This leads to some color flicker, but I think the video illustrates a point. Notice that we can segment into buses, automobiles, jeeps, trucks. We can also find people, road signs, and other items of interest in the scene. See, relatively speaking, how well the segmentation aligns with the vehicles. The predicted boundaries of the vehicles matches our perception of the vehicle's boundaries quite well. See how we can locate traffic from behind, from in front, from the side, and at all angles in between. I think this series of slides really illustrates the power of semantic segmentation. Here we're looking at the front of an entire aircraft from above. Now, we're also getting detections from the side. This is quite a very different shape to the top profile. Here you can see how well semantic segmentation can work on partial images. This is just a part of a plane, but this one has been segmented quite well as well. In this image, we've placed the airplanes further away. Again, these aircraft are identified quite reliably. In this picture, we've been able to identify a jetliner from a partial view of the front of the aircraft. Let's make it even harder, shall we? We can identify a jetliner from below. Again, a very different shape to the examples I've shown already. Let's make it even harder. It's capable of identifying a small single-wing aircraft. That's quite a different shape to any of the previous ones we've shown. Okay, what about a biplane? That works as well. That's also identified as a type of aircraft. Finally, it can also detect multiple aircraft even when they're on their side. Again, radically different shapes to the other successful detections. So you can see how powerful semantic segmentation is and how similar these algorithms operate to how we humans think about aircraft.